Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 2 from the specimen paper of the 9709, paper 4, Mechanics M1. This is for the syllabus that was started in 2020. It's currently the syllabus right now when I'm talking in 2024. Now, it says a constant resistance of magnitude 1,350 newtons acts on a car of mass 1,200 kilograms. The car is moving on a straight level road at a constant speed of 32 meters per second. Find in kilowatts the rate at which the engine of the car is working. Okay, so the rate at which the engine is working is the power. Okay, as you can see, the units is watts. So the power is the rate of work, the rate that the work is being carried out. Okay, which is basically the work done over time. Okay, and it's also the force exerted times the velocity. Okay, so the work done over time, which is the same as the force exerted times the velocity. All right, so those are the two equations we need to know for power. In this case, we know the force that's exerted. Okay, that's basically it's working against this gravitational force, right? This resistive force is working against it, so it has to generate the power to resist it. So that's the power that's the force it has to generate, and it's moving at a speed of 32 meters per second. So you have 1,350 times 32, and that will give you your power. That will be the answer for this question. So we take 1,350 and we multiply that by 32. That gives us 43,200 watts. Okay, so there's the answer to that question, but we want to write it in kilowatts, so we have to divide by 1,000, so we say 43.2 kilowatts. Okay, 43.2 kilowatts, that is the power generated by this car. Okay, so there's the answer to that first part. Now, the second part. Okay. We're going to have part B. All that space for part A, that's a bit unnecessary. Anyway, let's just do part B then. It says, the car travels at a constant speed down a hill inclined at an angle of theta degrees to the horizontal, where sine theta is 1/20, with the engine working at 31.5 kilowatts. Find the speed of the car. Find the speed of the car. All right, so now, so you have a inclined plane downhill. So I'm going to draw it like this. It's going downhill. Okay, and it's inclined at theta degrees to the horizontal. So that's theta degrees to the horizontal. All right, and so let's say this is the car. I'll just draw a little block here. Okay, now we know the mass of the car from here is 1,200 kilograms. Okay, so that means its weight, which will act straight down, okay, is 1,200 times g newtons. That's its weight, acting straight down, right? And the engine is working at 31.5 kilowatts. So the power of the engine is 31.5 kilowatts. Okay, so we've got to find the speed of the car. All right, so this is the driving force of the car, I'll call it D. We have the frictional forces acting between the car and the road, which we know already, which is 1,350. Okay, newtons, that's the resistive forces. We also have the reaction between the car and the road, which is R, okay, which I don't think we actually need here. So we want to find the speed of the car. So we know that the power is equal to the force exerted by the velocity. So we've got to find its resultant force. Now, we know that it's going at constant speed, okay? That means the acceleration is equal to 0. This is a key here. Constant speed down the hill. That means the acceleration is equal to 0, okay? So if you think about the driving force and what it's working against, which is this. Okay, then what we can say here is the driving force plus the gravitational force, which is going to be acting in this direction. Okay, let me change the color to make it show. I'm basically resolving the force now in this direction. Okay, which is 1,200 G times, now this angle is theta, okay? And when we resolve the force in this direction, we're going away from the angle given, so we're going to use sine theta. So this is 1,200 G times sine theta. That's this resolving the force in the direction that's moving. So we have D plus 1,200 G times sine of theta is equal to the force that is acting opposite it, which is the resistive force, which is 1,350 newtons. Okay, so the resultant force is 0, so the forces acting down and the forces acting up the plane will be equal to each other because it's going at constant speed. That's the key here, right? So that constant speed is important for us to understand how that fits into this particular question, right? The words are not here just for decoration. They're here for a reason. So now we can find the driving force, all right? We know the power, so therefore we can find the velocity, right? That constant velocity that it's going at, basically. So we know sine theta is equal to, as they told us, 1/20. So we know the value of sine theta. We know G is going to be 10. So we can say D is equal to 1,350 minus 1,200 times times 10 times 10 over 20, basically, because you multiply 1/20. So those will cancel there. You're going to have those cancelings. That's going to be 600. So it's 1,350 minus 600. So D is going to be 1,350 minus 600. So D is going to be 750 newtons. Now we know that D is 750 newtons. We know that the power is equal to the force times the velocity. So the power is equal to 750 times the velocity, which is, we know the power. So we can say the velocity equals, we're trying to find the velocity. We know the power. So I say velocity is equal to the power over the force, okay? Okay, so it's the power, which we're going to call P, over the force, which is the driving force that we found here, which is equal to, the power was 31.5 kilowatts, so that's 31,500 watts over, you should use it as watts in the formula, over the driving force, which is 750 newtons. So we take 31,500, divide it by 750, and we get 42. So the velocity is 42 meters per second. Okay, that's at the point where it's going at its constant velocity down the hill, right? So that's how we do with such a question. All right, you want to find the velocity. Okay, we can use the formula P equals F times V. We know it's going with constant acceleration. Okay, and so we can use the fact that we know the power, and we can find the force because the driving force, because the forces will balance out because it's going at constant speed. Okay, so there's the answer to that part of the question. I think that was it. Yeah, so that's question number 2 done. Okay, all about power and work and a bit about inclined planes. So other questions, as I said, from this particular paper, the specimen paper, you can find in the playlist that will appear in this region at the end of this video. Other questions dealing with work, energy, and power, you can find it in the playlist over here. And power specifically, you can find questions that deal with power over here. And you can subscribe to my channel by clicking on the link that will appear at the top. Thank you for watching, and see you soon.